Now for each of these identities, before we look at the proofs that you guys have provided, it says determine the non-permissible values of theta. Well, we're actually, you know what, we're actually going to look at the proofs first, and then we're going to determine the non-permissible values, because you have a non-permissible value when you do something you're not allowed. Okay? And in this case, the only thing that could possibly come up is with fractions dividing by 0. So we have to look at all of the places that you would have fractions in this and then figure out what your non-permissible values are. So I'm going to go to a proof that was done here. This one is done wonderfully. They changed everything to sine and cos. So can you see that they changed the cotangent to cos over sine, the cosecant to 1 over sine, and then they multiplied by the reciprocal, and we get this, that the proof works out. So what I'm going to do now in red is I'm going to circle every place that we divided. Okay? We divided here, we're dividing here, we're dividing here. We're dividing here again. And I'm circling all the places where we're dividing where it might be that that function equals 0. So when we look at all of these things, notice that 3 of them are sine theta. Okay? The one here that's cosecant theta actually never equals 0. So we don't have to worry about that one. But this place, the fact that we're dividing by sine of theta for our non-permissible values, we have to figure out when is sine theta equal to 0? What are all of our zeros of sine theta? Well, from 0 to 2 pi, that would mean that theta can't equal 0, pi, and 2 pi. That would just be between 0 and 2 pi. If we wanted to write the general solution for this, all the solutions, we would say theta can't equal, and this is a shortcut. If you wanted to take all 3 of those and add 2k pi, you could do that as well, right? Because that's sort of what we've been doing for the general solution. You'd solve all of your answers between 0 and 2 pi and add 2k pi. In this case, this is one of the ones that it does make sense to do this shortcut, because there's like 0 pi is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So it's easy to write it as k pi. So those would be our non-permissible values. So what you do when looking for your non-permissible values is you do your proof and you look at all the places where you're dividing. And then you have to check, if I'm dividing by sine, then sine theta can't equal 0. In this case, that's the only thing that we're dividing by that does equal 0. Cosecant of theta never does equal 0 because cosecant is 1 over sine. And if you think about 1 over sine, it might make sense. Here, I'll just talk about that a little bit. If cosecant is 1 over sine, and you're asking, when is a fraction equal to 0? Can you give me an example with numbers of a fraction equal to 0? Can you give me, I would like an example of fraction in fraction form that's equal to 0, using numbers. 0 over 1. Does anyone have a different one? That's right, that's equal to 0. Perfect. 1 over 0, that would be not allowed. Okay, but I want another fraction equal to 0. Different than that one. 0 over 2. Excellent. Can someone tell me another one? 0 over. Well, you got to put a number there. 1,265,020. Did I get that right? Yes, that is equal to 0. Took a little bit longer mental math there. What's in common with a fraction equal to 0? Now, there's a purpose. I'm not just doing this to be silly. Right? When a fraction is equal to 0, the numerator has to be 0. Okay? There's no way, if I put a 1 up there, there's no way you can put a number on the bottom that makes it 0. You might be tempted to put a 0 here, but that's not allowed. Right? That's just bad. So, when we think about, and the reason I showed you this, is when we think about cosecant of theta, and we know that it's 1 over sine theta, we can say just by looking at that fraction, 1 over sine theta, that it will never equal 0. Because the only way a fraction can equal 0 is if the numerator equals 0. And the numerator here is always 1. So that's how I knew that cosecant of theta would never equal 0. Okay, so this here, I'm going to erase the red here. This is a great example of a proof. Change things to sine and cos. Got a fraction on the top, a fraction on the bottom. Simplified to a single fraction. And as soon as they simplified to a single fraction, everything worked out. Now, I'm going to look at some similar ones that have tiny little things that are missing. Okay, and I want to talk about that because there's such common mistakes that I want to talk about them so that if you're making those mistakes, we can avoid them early. Okay, this first one. See if you can see what went wrong and where. Okay, so what do we see? Cosecant is 1 over sine. And so here, cosecant just got changed to sine. So again, what's really nice about this solution is the space is there, and it's really easy to see what the mistake was from how it's organized. So they forgot to change cosecant to 1 over sine, or maybe they did it in their head and just didn't write it down. And then when they multiplied by the reciprocal, they brought it back correctly, and then everything worked out. So it's kind of like maybe a bit of luck, but maybe a very common thing that students do is you make a mistake by accident to begin with, and then you're like, it's not working, so I need to undo my mistake to make it work. Don't do that. Sometimes in the marking guide, they might go, this is a 1 mark mistake because this to here doesn't make sense. It's a little mistake, or maybe it's a half a mark mistake. And then there's another half a mark mistake because you mistaked to unmistake your mistake. Is that, I don't know if mistaked is a verb. So you don't mistake to unmistake a mistake that you made. Okay? Yeah. So if you invent something to make it work out, it's going to end bad for you. Because the way that these are marked, they're looking at the details. They're not like, oh, I'm going to ignore everything. Oh, cos is equal to cos. They must have been able to do it. So don't make up stuff when sometimes it's better just to stop. If it's not working and you don't know where to go, just stop rather than making up stuff to make it work. Right? This isn't history class where you're like, I don't know how to answer this essay or paragraph question, so I'm going to write everything we learned that I know about, and maybe I'll get some points that way. All right, this one is a little bit. So this says 1 over tan, this says 1 over sine, this says cos over sine, 1 over sine. They put the sine in brackets with the cos. Well, I think they're trying to show here that they're multiplying. That's not too bad. No thetas anywhere. So they're missing a oh, that's green on green. That's bad. No theta there, 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 no theta there. Oh, there was one there. Okay. Oh. But there's no theta there, there's no theta there, and there was one there. You forget a theta once, the mark is deducted. And sometimes it might be that just off to the side you just want to go, oh yeah, tan is sine over cos, and you're like, well, that's really messy, but you want to write it down quickly, but you don't write the thetas. That's a half a mark deduction. Tan by itself doesn't make any sense, okay? Think of your name, take the last letter off of your name, and imagine that's what people are going to call you all day. Wouldn't quite make as much sense. Okay. The second proof. So the second proof here, cos theta is 1 plus cos over 1 plus secant. Here is a nice proof of that one. Again, we're going to change everything to sine and cos. What I like about this question is notice in line 1, 2, 3, 4. Okay, at this line right here, we've got a single fraction on the bottom. And the hard part to see is that on the top, and the top is 1 plus cos theta, that can be written as a single fraction. And the person did a good job of writing it here. The top can be written as 1 plus cos theta all over 1. And so this idea of if I change things to sine and cos, and I've got lots of fractions, I get a single fraction on the top, a single fraction on the bottom, then I can multiply by the reciprocal. This one worked out really nice that these things canceled out, and everything works out. All of the thetas are written, so that works out great. So now when we look at this one for our non-permissible values, so if I start circling, where are there places that we're dividing? Okay? We're dividing by 1 plus secant. We're dividing by cos. We're dividing by cos again there. We're dividing by cos again there. Here we're dividing by 1 plus cos. So all of those things come into play. We have to say that cos of theta cannot equal 0. 1 plus secant of theta cannot equal 0. And 1 plus cos of theta cannot equal 0. If we solve all of those, then we'll figure out all of the non-permissible values. Let's do the easy ones first. When is cos of theta equal to 0? Here, I'm going to spread these out a bit. I'm going to put this one last. Theta can't equal pi over 2 anywhere else, and 3 pi over 2. So what we're starting to do with our zeros, we learned our zeros in chapter 6. But now we can sort of apply the general solution to our zeros, and it might be easier than what we did in chapter 6. So if we want to say all of the solutions, we can take theta can't equal pi over 2 plus 2k pi and write our general solution. This is one where you could have just done pi over 2 plus k pi because they're halfway around the circle, but this would be fine. Okay? The second easy one, 1 plus cos, whoa, we'll leave that O right where it is. If I rearrange this, this would tell me that cos of theta could not equal -1. When does that happen? Not at 0. Cos is 1 at 0, just at pi, right? So if we did the general solution, we would add 2k pi, where k is an integer. Now, how are we going to solve 1 plus secant theta equals 0? Well, and this is going to lead us into our next question. We change our secant to cos, because that's easier to work with. And then solving this, well, if I have a fraction, can you see that if I multiply everything by cos, I'm going to get, so I'm going to multiply this by cos theta. This will get rid of my fraction. multiply both sides by cos of theta, and then I get cos of theta plus 1 can't equal 0, and we notice that it's the same. So we've already done it. We could do it again if we wanted, but it's exactly the same as what we had up there. Cos times 1 is cos. This will be cos over cos, which is just 1. And then 0 times cos is 0. So those are solving for your non-permissible values. Basically, it's like solving for an equation. When we write non-permissible values, that's when we write the equal sign with a line through it. When you write asymptotes, or if something said list all the zeros, then you would be writing an equal sign. Okay, the questions you can do for practice on this one are 4, 8II, 9II, and 11. But we are going to continue right now